For atmosphere and weather 2, what we're going to be discussing is we're going to reiterate the Coriolis effect. We're going to be talking about how moisture gets into the air, relative humidity, how does the moisture come down out of the sky as precipitation, and what are the different types of storms. All are about redistributing the water and energy throughout the atmosphere. Again, for the Coriolis effect, multiple things that we need to remember here is that with the Hadley cell, the air is coming down at 30 degrees north. Now, when it comes down to 30 degrees north, it has to go both south and north to replenish the air that's going back up here and going back up here. Now, if we're in Texas right here, and the air is coming down, when it goes back up, it's going to move because it's going faster than what the ground is. Okay. And so then what it would be up here. And so it's going to be tending to go up that way. Proof of that is if you've ever taken a plane from LA out to New York City, it takes less time to get to New York City than it does to take the other way because you have a very, very fast tailwind. That would be, the opposite would be true between 0 and 30. Where going west, in that case, you would go faster going west than you would going east. Relative humidity is basically the idea that for a given given temperature, if you have a given amount of water in the air, early in the morning it may be 100% humidity. But for that same amount of air, later on the day when the temperature has gone up 15-20 degrees, it may be down to 30 to 40% humidity. It's the amount of air that can be in there. Now, how does moisture get into the air? It basically goes up depending on what the temperature. If it's in equilibrium, the same amount of air the moisture is going to be going up as what's going to be coming down. In cooler air, when we typically have precipitation, there's less, it's not as warm, and therefore there's not as many molecules going up as what there is going down. Counter to that is with warm air, there's more going up that's coming down, and therefore it's not going to be as much moisture in the air. And let's look at this visually and see what's happening with this. Again, one of my favorite videos.
How much do hurricanes weigh?
Yeah, how much?
Well, it starts small with a simple white puffy cloud.
There's not a cloud in the...
And you ask, how much water is in that cloud? How much does it weigh?
Well, it's like floating around, so it can't weigh much.
We looked it up, and you're going to be surprised.
Okay.
The answer is it weighs about 216,000 pounds.
No way.
Which is roughly the weight of 2/3 of a blue whale. So that's a lot of water up there hanging in the sky.
So if it weighs so much, how come the cloud just doesn't fall down?
Well, here's why. Look under the cloud, and what do you see?
Just air.
Okay, but now what do you see?
Something.
Right. Under most clouds, so this is totally invisible in real life, you will find a warm current of air rising up. You know warm air rises,
Yes,
right?
I know where it is.
And if you zoom in, you can see rising molecules of warm air pushing up, while the water droplets, all those drops, they can't fall because the rising air won't let them fall. As long as the air pushing up is stronger than the droplets coming down, the cloud stays floating in the sky.
And that's why they float?
That's the main reason.
Okay, so we know how heavy a white fluffy cloud is and why it floats. What about one of these storm clouds?
Ah, you mean one of those dark at the bottom?
Yeah, the cumulonimbus.
Yeah, you mean a typical cumulonimbus cloud. It weighs about 105.8 million pounds. That's 353 blue whales worth of water.
That's
a whole lot of water that at any time could die. Which brings us, this being the season, to hurricanes. So how much does a hurricane weigh?
I don't know and I don't care.
Well, the numbers here are kind of staggering. A typical North American hurricane carries roughly 108 billion pounds of water. Now that works out to something like the weight of 360,000 blue whales, that's more blue whales than there are on this planet, moving across the sky. Hurricanes, you should know, are immense water-moving machines. They take water from one part of the planet and they drop it on another part of the planet, and the volume, the weight of all that water is enormous.
Okay, so the amount of water that's in the air is dependent on the temperature. And it's going to be more in the air, more moisture in the air if it's cooler. Now, 40% of the Earth is covered at any point in time. Now, if there's a cloud up there, it's white. And because of that, there's not going to be any light absorbed by it. It's all going to be reflected. Therefore, it's not going to warm that area up. Reflecting sunlight is known as the albedo effect. Okay. And that actually is very, very important, because as we're getting warmer and warmer due to global climate change, there's going to be less and less ice. And therefore, there's going to be less albedo, and therefore, we're going to start warming up faster. Kind of scary. Now, what happens is as a cloud warm goes up, it's going to push up because of it hits the Earth. It's going to change from visible light to infrared, and it's going to push the moisture up, causing the cloud to appear if there's enough moisture. Now, there are various types of precipitation. If you do remember precipitation, because we're in the middle of August and there's not been a lot of moisture yet lately. So rain is basically, it's a sphere. Unlike what a lot of people think, it is a sphere. It's not a teardrop, but a sphere. It's fairly small, but it goes. And freezing rain is when rain hits the ground and it freezes. That's very, very dangerous. Why? Because you don't see it, and therefore if you're driving and you hit this frozen ice, this ice that you can't see, it's going to be nasty. Sleet hurts. They're tiny, tiny, tiny ice pellets that usually develop in strong winds. And if they hit you, it hurts. Snow is that pretty stuff you see in the movie Frozen, where it has 6 different sides, and it develops as it's coming down. Snow pellets is where, as it's coming down, it starts to warm up, and it forms into grain and then cool off and forms into ice. Hail, on the other hand, is where you've got concentric rings of ice. The reason why you have that concentric rings of ice is because as it goes up, as it wants to come down, it hits, as it's wanting to come down here, it hits a flow, and therefore it circles and circles and circles. And as it does, it forms more and more moisture on the surface, sort of like Shrek, where it's got layers. And if you actually cut a hail in half, you will be able to see the layers of Shrek. Of the water. Now, winds go from high pressure to low pressure, sort of like diffusion, high pressure to low pressure. And as they move, if there's a bigger difference in high pressure to low pressure, it's going to cause more of it to move faster. And the Coriolis is going to tell us how much is it going to bend, how much is it going to spiral. Now, they can be detected by something called an anemometer, and basically, and the direction is by a weather vane. Okay. Now, a front is where basically a warm front is where we've got warm air encountering cooler air. As the warm air comes in, it rises over the cool air. As it rises, it develops clouds, and some of that precipitation in the warm area comes out. On the other hand, if we have a cold front, it's going to push under the warm air, causing it to rise, and that's going to cause a thunderstorm because it's going to go up very, very fast. Now, thunderstorms are fairly nasty. They can occur basically anywhere, and they will give us strong winds, lightning, thunder, rain, and tornadoes. Okay, again, because it's going up very, very rapidly, they can go much, much higher than the regular cloud. And then you're going to have the rain and the hail and the like. Sometimes with tornadoes, where you're going to be basically having this spherical motion in there, it can be very nasty. They can be over 300 miles an hour, spinning, and it can destroy everything in their path. They typically happen someplace between Texas and Indiana in the United States. But it can occasionally happen elsewhere. Severe weather is in hurricanes is where it comes up. It starts in the tropics. It starts spinning, and it basically doesn't go over anything over 74 miles an hour. But what's interesting about these guys is that it's got the eye of the hurricane, where it's basically going this direction. And what's nasty about it is as it's going this direction, over here, all the trees are going to be bent that direction. And then when this moves this direction, it's going to go from when going one direction to the other direction, which can be very, very damaging. Okay, but how do they start? Well, if you're over a warm ocean, the warm air is going to rise. And if there's more and more of that rising, because of the tropics, it's going to start spinning. And if the conditions are right, it's going to form the hurricane, and it's going to basically be very, very large and very, very destructive. This is just looking down at the eye of a hurricane. That can be multiple miles in diameter. And this is just showing how it's coming up. It's spinning, and it's going to go over land, which means it's going to slow down. If it then goes across the land and it goes on the other sides and goes over warm water, it's going to speed back up. This is just looking how a certain hurricane follows a path, and if it goes along here, it's oftentimes going to go back out along this region. If it comes down in here, it frequently comes up in this region. This is just kind of cool pictures dealing with the edge of a hurricane. That color right there is very, very scary, where it's a blue-green, because that's indication of hurricane, hail, and or tornadoes. Just the edge of the hurricane coming across is fantastic. This is a beginning of a huge tornado coming down. Again, scary skies. You might want to. That's the green you want to watch out for. Whenever people in the Midwest see this color, they watch out because they know that there's going to be hail or tornadoes. And this is a tornado. Notice how it starts spinning up here, but it also starts spinning down here. It doesn't always connect. When it does, it means it's stronger and stronger and stronger. This is a category 1. They can go up higher and higher, up to almost a mile across.